Alright, here's part B of lecture 3 with the OLS formulas that we're getting into the details, and I kind of explained what these parts mean. Let's just go ahead and do it. We take each y value, the prices, and subtract the average, 8. So I'm just going to set up a formula here. Equals B2 minus 8. Just copy it down. All right. Excel's great at helping with calculating these things, even if we're kind of doing it by hand here. Then take each x, subtract 6, the mean, and so equals A2 minus 6. I'll just do it that way. Okay, let me make all these numbers bold and make them stand out a little bit more, and I'll center them. And each of these numbers squared. We're going to need that in the bottom of the formula here, so I'm going to go ahead and square those previous numbers, the xi minus x bars, so equals d2 squared. Now this wouldn't be too hard to just do on a calculator or do in your head for the most part, since these are simple numbers. Alright, what do we need to put in the formula? Well, we need to multiply the difference in each y from its mean, column C, times each x from its mean, D. So I needed another column over here. Yes, you get into a lot of columns when you do this. Think about before we had computers and calculators. So I'll just call this C times D for shorthand. Now, if you're doing this for a class, you need to do this more neatly than I do. So C2 times D2 equals C2 times D2, and I'm going to copy that down. Okay. The top part of the formula. Take each y, subtract its mean. Take each x, subtract its mean, multiply them together. We've done that. Last thing, this sigma is the Greek that reminds us to sum, to add things up. And we can hit I'm going to hit the auto sum key over here in Excel that you can't see, but it's the Greek letter sigma in Excel. That's the sum. That's the top part of this formula is just 23. Sorry, minus 23. That negative is important. We don't want to forget it. So minus 23. Now the bottom part of that formula, take each x, subtract the mean, square it, and then add them up. Okay, well, we've taken each x, subtracted the mean, we squared them right here, and now we just need to add them up. And we get 26. So we have 23 divided by 26, negative 23 divided by 26. Let's see what that gives us. Equals minus 23 divided by negative by positive 26. You'll notice as you go through these lectures, minus signs are what kills me as a mathematician. This is always true. So minus 0.88462, that is the slope of the line that minimizes the sum of the squared residuals. So I'll just call that the slope. Now, you have to calculate the slope first before you can find the y-intercept. Look at this second equation. Our estimate b hat of b hat 0, the y-intercept, is you have to know the average of the y's minus the slope times the average of the x's. And so in order to calculate that, I can put in a formula here into Excel. Equals the average of the y's, 8, minus what? The slope, which is a minus 0.88462. Don't let these minus signs mess you up. Times the average of the x's, 6. And I'll show you what this formula is doing in just a second on the graph, since I like to visually look at things. Y bar minus 8 minus slope, which is minus 0.88462, times x bar, 6. What do we get? 13.30772. So this is telling us that the best equation would be that price, the y, equals 13.30772 minus 0.88462 times x, which is the quantity. Alright, so let me make this bold so we can see that a little better. That's our best equation that would minimize the sum of the squared residuals. Now, let's do two things. I want you to show you what this formula is doing. But first, I want to calculate the residuals and show you that this equation does indeed minimize the sum of the squared residuals for this data. How are we going to do that? Well, we can do this by hand, but I'll get Excel to help us here. Here are my new residuals. Call it the new E here. Well, before we do that, I need to do the new predictions. Y hats are what we call these. Using this equation, what price should we see, according to this equation, for each of the quantities that we actually see in the data? So here are our actual quantities, 3, 6, 5, and 10. I'm going to plug 3, 6, 5, and 10 into this equation and see what predictions we get, because we need those predictions to calculate residuals, errors. And so a formula to do that would be equals 13.30772 minus 0.88462 times A2, the quantity. For our first, that's our first prediction. I'm going to copy these down. And so we get 1, 2, 3, 4 different predictions here for our best line. Now I want you to notice something interesting that is always true. The best line always goes through the average x, which is 6, and the average y, which is 8. Always true with the best line that minimizes the sum of squared residuals. So if you're ever trying to figure out what that line is, start with that point at the averages and work out from there. Now what are the residuals? Actual price, 11, minus predicted, 10. So let's calculate these. Equals B2, actual minus predicted, G2. I've got those calculated. And now, again, the measure for the best line, the benchmark is make the sum of the squared residuals the best. So let's square them and sum them. E squared. I'm going to do H2 squared. And as always, notice, if you have a residual less than 1, you square it, it gets even smaller. I'm going to add those up. Look at my sum of squared residuals. It's less than 18, about 17.65. My residuals got smaller than they were before, and my sum of squared residuals is also smaller. Let's go back to the other sheet. What was my sum of squared residuals before? 50. Now, with the best line, sum of squared residuals, less than 18. We've cut it much more than in half, using these formulas to find the best line. So let's graph this line, this equation, 13.3 minus 0.88462. It's going to start at 13.3 on the y-axis, the y-intercept, and we just need one more point. What if x equals 10? 10, what would our prediction be? 13.3 minus 10 times that, which will be 13.30772 minus 8.8462. Another point will be quantity 10, price 4.46. Let me draw that line very quickly before I run out of time so we can compare the two and see what they look like. Starting at about 13.3 and going down to about 4.4, This is the best line. Let me change what it looks like here a little bit. I changed it to kind of a red. Let me also see if I can change the thickness. Oh well, it's going to take me too long to do that. You see how this new line is better, this orange line? This residual is almost 0. This one's almost 0. This one's about the same but a little smaller, and this residual's smaller. That's how it makes the sum of squared residuals much smaller than it was before. So I'm going to end here, and I'm going to pick up in a minute with some of these other formulas that are important when evaluating a regression line.